Okay, hey, good morning. Can you hear me okay? There you
Yes,
go.
I'm currently unmuted.
I can hear you now. Well, welcome. Well, thank you so much for doing this and spending time on a Sunday. I know a lot of people have better things to do on Sunday.
I
And
actually feel a little bit of guilt of taking everyone's time because today is Richard Branson's launch of himself and his team into the space.
I didn't even realize that. So I guess I'm not paying attention to the world. Well, so he is doing what? How's he getting into space? What is he doing? Is he
Well,
doing Elon Musk style, or what's he
he
doing
has
with his
a
planes?
mothership that carries his own spaceship. And then the goal is to demonstrate the feasibility of commercial space traveling.
I see. So he's going to get up people in a commercial airline, which is attached to a already orbiting spaceship, I guess. Is that the plan?
Their Virgin Atlantic have their own mothership that carries the spaceship into the launch pad, and then they will launch them into the space and hopefully make a safe return. Yeah.
And so they're just going to go out into the near space just outside of our atmosphere and fly around for a little bit and come
Right,
back, right? Okay. So
right, right.
that's pretty cool. Well,
Nothing.
I honestly don't know how many people were waiting on that today. Maybe I'm living under a rock. I didn't even know about that. But I just got in. I got in late last night and midnight. We went up whale watching in one of these. I'm in the Pacific Northwest now, and
Right.
we got back very, very late last night. So I was getting I always have to take the dogs for a walk and do all this kind of morning stuff. So I was literally almost running back to get here on time. So I apologize. And then I always have to, there's a few technical things I have to do to start this meeting. But anyway, well, we're, first of all, thank you for doing this. I was scrolling through our success stories and Meter X as I do every periodically to kind of see what the latest thing. And I saw your story in there. It's pretty recently. I said, that's pretty cool. And I saw you're an MD, PhD. Well, it's also neat to see, more healthcare providers. So we have quite a few already, but it's always neat to see more. And then I saw you're coming on as a guest, and I thought, oh, that's awesome. That's wonderful. So I'm looking forward to it. So and make sure, and hopefully I'm saying that correctly. I don't want to mispronounce your name. It's you say it.
You said it
Hui.
perfectly.
Okay.
Hui. Yeah.
Okay. Where are you at currently? And tell us a little bit about your background, if you don't mind.
Sure. So I'm currently a MD PhD in training, and then I'm in the PhD phase of the dual degree training. My degree granting institute is Albert Einstein College of Medicine in New York City, but my research is very actually pertinent to what we're talking about today. To put it in layman's term, I study what drives human to eat. So my research thesis received a fellowship awarded by Howard Hughes Medical Institute, which is the largest and arguably the most affluent private funding research agency in the United States. And I received this reward and is currently conducting neuroscience research on the neuroendocrine control of food intake on their Genelia Research Campus, which is based in Northern Virginia, just outside of Washington, D.C. So that is where I'm currently based. And this is my office in the lab building. Actually, in the background, you see a bunch of kind of intricate optical instruments that we use to image the mammalian brain as our model organisms, such as a mouse or a rat, perform, say, food seeking or food procurement behaviors.
That's fascinating. So I know it drives me to eat. It's usually me being hungry, but I mean, I know it's so simplified. I guess, and when I was going to medical school, I remember the MD PhD students, that you do the first 2 years of the kind of the coursework, and then you'd stop,
Right.
they would jump away and do their PhD, and then they come back and do their clinical stuff. Is that still how it works?
Exactly, it
Yeah.
is, still
Okay.
is, yeah. Well, for this meeting, we can delve into my personal story. I also prepared a little presentation to show the community how neuroscience try to understand the brain's control of feeding behavior and how different macronutrients contribute to ensure the proper meal size and long-term management of a healthy body weight and metabolism. So Sean, you choose. Shall I just give a little background of myself and
Yeah,
go
yeah.
into the
Yeah, let's
presentation?
do the background, then I'll let you share the screen, and we can go through the more formal presentation, because I think, I think this is the context at which this comes by. You've got some personal experience about what drives people to eat, what maybe drives people not to eat appropriately, since you kind of, I guess, kind of lived through that. So tell us a little bit your story, where you are now today, and then let's get into your presentation. I'd love to see it. We'll let you share the screen, and I'm sure our members here are going to be super excited about that. So go ahead and tell us a little bit about what happened with you.
Sure. So I became a vegan primarily for ethical reasons, not because from my research, I intuitively understand the value of meat-based protein. I absolutely, value it. But primarily for ethical reasons, I was a vegan from 2013 to 2019. And then that created almost a cognitive dissonance in a scientist like me, because on one hand, I try not to eat meat um, for ethical reasons. On the other hand, I know the crap I'm putting into my body wasn't really nutritious. So it makes eating a overall unpleasant and aversive experience for me. Um, and then I think that gradually morphed into a full-blown anorexic. And I was hospitalized actually by one of the top eating disorder and most intense eating disorder treatment program in the United States, which is conducted at the famous Johns Hopkins Hospital. At that point, that was in December 2019, I was hospitalized. At that point, the normal or the slightly less intensive, say fully inpatient treatment, residential treatment wouldn't even take me because my weight was too low. So I went into Hopkins, and basically the way they fed you is they fed you the SAT diet, and then they make you weight restore as fast as possible. I think the primary goal is to kind of cranking through as many patients as possible and make sure that no patients die in their hand. Basically, I
Well,
don't think
let me interrupt, because you said you're too low. What was your weight when you went into this facility?
so. My lowest weight in 2019 was 69.5 pounds, and I'm about 5 foot tall.
Wow, that's amazing. That's obviously very, very thin. And how did you, I mean, I know I want to talk about how you went through recovery, but how did you get down there? I mean, how was it like that you just continue to lose and lose weight? I don't know where you started when you went vegan, but I mean,
I I was on the research campus, and then there's a lot of pressure to produce. So I was eating a vegan diet, just blending giant smoothies. It gives you transient feeling of satiety. If you drink just like 2 gallons of smoothies every day. And I was doing a lot of crazy kind of obsessive cardio as a stress releasing mechanism. I think from the genetic study, GWAS study coming out of the Karolinska's anorexic study, they show that people who have a genetic predisposition to anorexia, no matter how they get into a caloric deficit, they can get into such a deficit state by simply not eating or by simply doing more cardio than the calorie they take in. Once they get into this state, they down spiral. It's hard for them to self-correct their energy intake and output behavior.
Okay. So now you get into this Johns Hopkins, and I'm really surprised. This is the thing that's kind of a little shocking to me. Why would people turn you away when you're in such clearly life-threatening situation? I said, we're not going to take you too thin. It doesn't make sense to me. What is the rationale
You are a
saying?
liability. So their facility is not equipped to treat such severe cases. If you refeed and then develop refeeding syndrome and die in their facility, they don't have a ER attached to them to handle you if you develop refeeding syndrome in their facility. I
Yeah,
think
let's talk about refeeding syndrome. Tell people what that is. I mean, it's obviously there's electrolyte imbalances that occur, and you can die from that. But what is the concern about refeeding syndrome for the people that have not don't know, aren't familiar with it, I suppose.
Exactly. So especially when someone who is metabolically very suppressed, in the case of anorexic, or in the case of say hikers who survived in mountains that survived an accident, and after long periods of starvation, the way Hopkins program feeds any patient is by the SAT diet. I was, eating 4,000 calories of pancakes and um, drinking ensure. So what happens is you rapidly accumulate fluids in your subcutaneous and interstitial compartment, which manifests as my skin was cracked from the heel to the shoulder. It literally just cracks open because the fluid was sipping out of my vasculature system. And then what that happens is you can maintain the correct amount of sodium and potassium concentration inside of your cell versus out of your cell, and that can throw particularly cardiac cells, that the cells in your heart that paces your heart into just a frenzy, and then your heart can just abruptly stop. That's like arrhythmia developed from a refeeding syndrome. And then you trace back this particular arrhythmia was due to electrolyte imbalance, but other symptoms can develop, say severe hypoglycemia, because your body is not used to produce enough insulin to handle the influx of carbohydrates they are feeding you. Yeah.
Yeah, my understanding, and I've looked a little bit in refeeding syndrome, is, when you refeed and you have this, obviously insulin will impact particularly things like potassium, magnesium, some of the other things, and you can actually produce arrhythmias and all kinds of stuff. So I'm really interested that they're the world renowned group, and yet they feed everybody a standard American diet to refeed. I mean, I don't, obviously I'm not the expert here, but it seems like there could be a better diet to refeed. But anyway, so you get there, and so what happens, as you get into Johns Hopkins?
I stayed there for 6 weeks, and then I insisted to be discharged because I really want to return back to my research work. And then after discharging, I was in a mentally very confused state because with outpatient follow-up with Hopkins, they wanted me to continue eating their dietary plan, which is basically a step down, but largely the dietary composition is the SAD diet. And then they were trying to kind of indoctrinate me the idea that you have to follow this meal plan to avoid physiological or psychological relapse. But at the same time, from my research, which I hope to show you briefly a little later, I know those are not nutritionally dense and optimum foods. So I sort of kind of from the bottom of my heart, I try to avoid eat it. And that spin into the avoidant aversive response to food again. So I was almost at the edge of relapse again. At one point, actually, just about I would say summer this summer it was from January 2021 that I started to notice I'm losing weight at a rapid pace, and I'm going down the hill of anorexic relapse again. And I couldn't allow myself to do so because that's going to compromise my research and academic medicine career severely. And so around the same time, I get to know just a cattle rancher in Kansas, to whom I'm really thankful to. I think knowing people like that, like independent ranchers and cattlemen, brings me really close to the land and the environment in our heartland that produces our food. It just gives me a psychological comfort to know that such a nutritious dense food come from a genuinely good man and human and other, a cattle woman too. So I started to research more, read more, and just eating a carnivore diet. And I've been doing greatly. And I think I stopped my like the train wreck of weight loss. And more importantly, I'm not gaining the water weight as in the case of refeeding by a sad diet, and I can feel the strength gain in my body was way more profound this time compared to last time when Hopkins fed me. When Hopkins fed me for a long period of time, I couldn't do a bare hand squat, because Sean, you probably know it's a severe compromise of your lower body and whole posterior chain strength if you cannot pull yourself up from a squatted position, right? So this time, I don't have this kind of sarcopenia symptoms by just try to refed myself and stick with a carnivore diet. And also because it's not flooding your system with a bunch of junk carbohydrates, you do not develop like the horrible maddening edema, because edema also um, it's very psychologically challenging because first you're visibly big in all dimensions in your body, and secondly you worry that you're going to drop dead the next minute.
Yeah, that's something that is, I mean, a kind of an amazing, because you go from a vegan diet, eating all these smoothies, losing weight, getting down to 69 pounds. They really feed you at Hopkins. They give you a bunch of junk food, pancakes and Ensure. You swell up, you're bloated from all the fluids leaching through your body, your skin's cracking open. You kind of get out of that and then get back into the same psychology that I can't do that. I don't want to feel this way. So I go back to restricting food. And then then you find a carnivore diet and you don't have the fluid, you don't have the fluid accumulation and the shifts. And what about your mental state? Because this is, and I'm sure we'll talk about this a little bit, but because your research is around the neuroendocrine system, but mentally, going
Yeah.
from a carbohydrate standard American diet to maybe a carnivore diet and dealing with, disordered eating, anorexia in your case, how did you process it mentally? What was it like mentally?
So Sean, to be honest, I think it was very fortunate for me to be able to talk to you in a kind of calm tone, like I guess just by me talking, I don't come across as someone who's agitated or forceful. Before, when I was very low, currently I'm still probably from my appearance, guys can see that I'm not obese or overweight or anything. Also, the pictures on your website, you can see I'm relatively a lean individual. And when I was anorexically lean, but was eating a vegan diet back in 2019 and before, I have I came across as a very kind of almost negatively high energy. My talking would sound like forceful. It's almost when I'm in a meeting, I'm almost overly worried that say my research data wasn't convincing. I wasn't talking in a calm and communicative way, but in a way um, try to persuade others, or try or in a way that expose myself as being someone who is severely insecure, which I was, because if you're anorexic, you know this, and you are self-conscious. You walk into a meeting room, you don't feel good about yourself, right? I think with carnivore, the greatest benefit is a sensation of calm and self-reassurance that I could derive.
Yeah, I mean, because you describe almost anxiety and mania, almost a hypomanic type situation where you're
Exactly.
just kind of just, pressured to talk. And, and that comes with, I think, worry and stuff like that. I wanted, before we go into your presentation, because you said you were a vegan for ethical reasons and you got to talk to the cattle rancher and see how the food is actually raised. How did that change your mindset? Because, a lot of people that are on this plant-based or vegan diet all their information comes from, vegan documentaries and vegan animal activists, and it's very skewed. It doesn't really represent. I've had the fortune to go to ranches, be around the ranchers, see how they treat their animals. I've talked to, literally dozens and dozens of ranchers throughout the world. What did you learn by actually talking to the people that produce your food?
Well, first, also, since this is a great opportunity, I want people to care about the individual cattle producers in America. First, I think it is important for me to recognize that in different areas in the world, if we truly want to make a contribution to reducing the overall effect of global warming and make our planet more sustainable, people from different area ought to do different things. Say for example, in America, we are producing higher quality of beef than anywhere else in the world at a most resource conserving way. In other words, for someone in America to try to reduce their impact of environment through not eating beef is not a smart way. If you take less airplane travels, or if you use less air conditioning, or build your house in a more ecologically friendly way, you're contributing way more compared to, refraining from eating meat. It has to be geographically, location-wise, strategic for us to contribute to the environment in the best way. And secondly, I feel um, the to understand how the life cycle of a cattle produced in America also motivates me to associate a lot of the politically oriented message. For example, how the big packers, I'm a fan for individual ranchers like the calf cow producers. I am not a fan for the concentrated for big packers in United States, period. And it is interesting to know that because packers, they process not only beef but also poultry, and probably Sean, this, Tyson and at least one more packer already have their foot in meatless alternative meats product. So when it comes to promote true nutritionally dense beef, they have a conflict of interest in it. That's why, say for example, NCBA National the Cattlemen's Beef Association cannot use their beef checkout funding to fund any research or any message that says beef is superior to another protein source. Even the protein source is going to be meatless protein. They can't allocate such funding to promote this message. So it really make me think. And also, the meatless, the promotion of meat alternatives is heavily tied into even more larger the political, kind of whatever correctness or the whole environment we're in. So it's really, and I have to personally admit, at least I'm a fiscally conservative person. I'm not afraid of saying it. I know I probably gonna get hatred from it. I overall don't think, I overall value markets, let me put it this way. So it really made me think deeply about a lot of the political message. I can't say that I have a very formulated thoughts about it yet, but just have something that allows you to think deeply, think calmly, and realize that you have something to learn, and once you learn it, you can maybe contribute. It's empowering feeling.
Yeah, obviously the four big packers in the U.S., they control 85% of the beef market, and they are, obviously they're invested in alternative proteins, and I think they're going to go with what makes them the most money. And so I think the need to continue to support our individual ranchers has never been more important than it is now. And you're right about the NCBA and the beef checkoff. The USDA kind of ties your hands a little bit about what statements are allowed to make. So
Correct.
let's, if you don't mind, let's talk a little bit about your research now. If you don't mind, I'm going to allow you to share your screen, and
Sure.
then if you'll pull up whatever presentation you wanted to do, you should be able to share your screen if you're familiar with the Zoom app. Yeah, there you go.
Okay, can you guys, do you guys see my screen right now?
We can, yeah, we see that. Neural control of food intake.
Sounds good. Okay. So I'm going to talk a little bit about the neural control of food intake in the context of a nutrient-dense food, namely beef. And I constructed the presentation in a way that's hopefully to be visually impactful and impressive to, I hope you remember some of the videos I'll show after this meeting. Let me see. You see the slides advancing, correct?
Yes, we do. Yeah, I can see a sagittal view of the brain right now. So
Sure. Yes, sagittal view. That's how, doctors talk about it. So
right.
we as neuroscientists who study how the brain control a feeding behavior, we think about the course of an eating event as that can be divided into 3 phases. Those 3 phases are etiologically relevant, which I will explain shortly. So the first phase is what we call the preparatory phase. This phase involves the sensation of hunger and the behavior that mammals or humans perform to procure food. For an animal, it could be hunting. For a human, it could be drive out to get takeout or, to prepare your own food. And this preparatory phase is mainly controlled by the arcuate nucleus in the hypothalamus. The hypothalamus is a deep part of the mammalian brain. It sits right above the bones on your nose. Actually, sometimes when people have a hypothalamic tumor, the surgeon will access through the nose to remove the tumor. The second phase is what we call the consumptory phase. This phase involves the orofacial movement, the mechanical movement that actually physically allow eating. For example, you would chew, you would swallow. Those are what the behaviors within the consumptory phase. This phase is mainly controlled by the lateral hypothalamus. If you think about it in a human, it's slightly higher than the arcuate nucleus in our head, so more towards the top of our head, and it's slightly more lateral compared to the midline structure. Arcuate nucleus is very midline. And the last phase is what we call the satiety phase, which is intuitive to understand. It involves the gradual development of satiety sensation, and then a human or a mammal with normal satiety sensing mechanism would gradually stop eating. And this phase is controlled by what we call the peribrachial nucleus. This nucleus is located in the midbrain and hindbrain boundary, so it is slightly more posterior compared to the first 2 structures in a human head. Next, I will show you how those neural nucleus and neural circuit that organized inside those little locations in our brain can potently affect our eating behavior. And then the ultimate goal of showing those videos is to hope to demonstrate that if you eat the wrong macronutrient composition, you cannot override your eating drive, meaning that the message that the government has been proposing, oh, just eat less and move more, you can't overcome this meat eating drive. We're not going to exercise our way out of this obesity epidemic. So first, I will show you, if you in a mouse, you activate the brain region that tells you you're hungry, what's going to happen? So this mouse, before it enters the experimental arena, it is fully sated. So it has all the food it wants to eat in its home cage. And this experiment is conducted during the daytime, during which the mouse typically sleep and refrain from eating. Now I'm gonna go in with the blue light and activate the hunger encoding brain region, and you'll see what happens. So the blue light comes on, the mouse was originally sleeping in this corner of the cage, which mouse usually hide in the corner. So it starts to retrieve food pellet from this food port. As you can see, it just keeps doing so. And the food pellet was not even hyperpalatable or anything. It just cannot overcome this drive to stop. It'll just keep going.
Hey, can I ask something real quick here? So,
Sure.
blue light as a stimulation, is that the actual stimulant, the blue light that's stimulating the arcuate nucleus, or is that this?
Exactly. It's activating a particular cell type, a group of neurons in the arcuate nucleus of the hypothalamus. Yeah, so the way it works is that the neurons express Sham, you probably, or other scientists here would know. So the neurons express a channel that can be opened by the blue light. So when it opens, it causes a calcium influx and neuron gets activated.
So,
So
I mean, and again, this is obviously a rat, but when we're looking at human beings,
it's a
constantly
very
staring at a phone.
abnormal voracious eating behavior, which it's like binge eating in human when we encounter something like donuts. Humans don't eat a piece of steak like this, right? We cut up a steak, we eat it, and we walk away. When you can't overcome this kind of hunger drive, that's how you display those abnormal binge eating behavior.
Okay, I want to see how I'm interested to see how this progresses here because I'm trying to figure out the connection between blue light and donuts right now, but I'm sure you'll bring that together.
Right. So it just gonna keep going like this. And then this is a water port because it eats so much dry pellets, it's gonna feel hungry and it's gonna go drink water so that it can come back and eat more of the pellet. And I have to remind everybody that the standard rat food that used in the majority of U.S. labs, including us, are formulated mainly by casein is a major component. Fructose is a major component. It's basically a combination of sugar and fat. And the most unhealthy type of fat that you get from, say, plant derived, because they're not going to spend all the money to extract fat from beef and put it in a mouse chow diet. So that's what happens if you activate the hunger controlling brain region. And then now I'm going to show you what if you use the same blue light, activate the consumptory controlling brain region, the second brain region that I introduced, which doesn't necessarily encode hunger, but actually will propel you to perform or display a eating behavior. When you activate that kind of brain region and provide the mouse with this is like palatable food, what you see on the floor was actually concoctionated specifically as the equivalent of donuts or fried something to mouse. Also a very unhealthy fat and sugar concoction. I'm just, maybe if I started from an earlier part, when the light is, if we start with the light off, the mouse walks around a little bit and light comes on, it activates the lateral hypothalamic region. You can see simply if you just activate the brain region that involves the mechanical movement of eating and you provide the animal with concoctionated artificial food just as what's been flooding our food environment. Whenever the light is off, the mouse walks around. Whenever the light comes on, it picks up those unhealthy food um, crumbs and start eating. I guess, those kind of research rarely get out of our ivory tower environment and be displayed to the general public. So I thought it brings something different to the community. I hope people are entertained by it.
Yeah, I wanted just a couple more questions. So when the blue light is on, when the laser is on,
Sure.
is the actual stimulus the light itself, or is that just indicative of the fact that there's an electrode stimulating the arcuate nucleus in the lateral hypothalamic nucleus?
It's the actual neurons in those brain regions are activated
By the actual light itself.
by the actual light itself, because
Okay.
the light causes channels. Channels are basically proteins on the cell surface to open, causing influx into neurons, and neurons become activated.
Okay. Now, I mean, most of us humans are not staring at a flashing blue light, and that's not what's causing us to eat, right? So
Right.
how do we, how do we extrapolate this information into human eating behavior, perhaps?
Sure. And what I will show you is that, so this is a stimulated behavior, but people decided to stimulate those brain regions because in the first place, they observe in a naturally walking around and behaving animal that those brain regions become activated when we just spontaneously initiate a feeding behavior. So when you spontaneously initiate a feeding behavior, which every human have to do in order to survive, then those neurons get activated. But if you eat the wrong type of macronutrients or food, it's just gonna perpetually become this voracious stuck in this voraciously activated states, and you develop overeating, binging, uncontrolled eating, inability to sense satiety, etc.
So do we have like, I'm just guessing, PET scans or functional MRIs that show when people eat these highly, palatable fats and sugar combinations that the arcuate nucleus has continued to be stimulated, or the lateral hypothalamic nucleus is continued to stimulate? Is that
Sure.
what we're seeing?
Sure, yeah, I'll skip a
Okay.
slide, skip slides. This slide's just to show you if you activate the satiety encoding brain region, that the mouse will truly walk away from food. So this is, the top is a different way of activating the satiety encoding brain region, but the bottom is activating it through a blue light. So if you could correctly activate your satiety sensing brain region, this animal will eventually, you see, it first was very engaged with the port, and then it'll eventually, it's still, because satiety developed gradually, which is foreseeable. After we stimulate it for some time, it'll walk away from the palatable liquid food port.
And is this the parabrachial nucleus that
Exactly,
they're just
that's the stimulation of the satiety sensing brain region. Exactly, Sean, you're right on spot. And then before I show you the human data, I just want to emphasize one more point where the arguably the obese individuals are at a higher risk if we specifically look at this lateral hypothalamic nucleus. So there's a specific type of neuron in this brain region that actually encodes sugar reward. So in this experiment, what the experimenters did was that they tried to fatten those rats up by feeding them basically a donut, high sugar. They used Ensure, basically the concoction of very crappy fat, mainly plant derived, and sugar. They fatten them up in the course of 12 weeks. And what this activated neuron encodes is that, oh, in a normal weight individual control diet, the green line, whenever you give it a sugar reward, it has a big bump in their brain, tell them, oh, you are getting a lot of calories because it's highly sugary. But in obese individuals, this response is dampened, as you can see, on a high-fat diet. So what the brain was telling obese individuals is that we need more. We're not sensing enough calories or enough reward from equally sweet sugar compared to if you feed the sugar to a lean individual. So sugar actually, the obese individual was at an even more disadvantageous point because its lateral hypothalamic brain region cannot even sense the same amount of reward derived from sugar. Thus, they would crave more sugar.
You know, I want to just, I apologize for interjecting here, but I mean, we see this with dementia patients where they don't, their brain almost becomes insulin resistant. And I wonder if some of these primitive, regions in the hypothalamic region also fail to properly, you know, deal with sugar in the same way. And then we see that because there's a relationship between obesity and dementia, and we see that with diabetics and dementia. So I'm just wondering if this, this continued insulin resistance in the brain is driving you to continue to eat more and more and more. I don't know if that's something you've ever thought about.
I think that's very possible, at least in the context of vascular dementia, because we know that the hypothalamic region is probably one of the most vascularized brain region. If you cut off blood supply to the hypothalamus compared to other cortical regions, your hypothalamus is gonna die way faster. And then there's a lot, so the demand for blood is high in the hypothalamus. That's why there's a lot of fenestrated blood vessels to make sure your hypothalamus has enough blood supply. Also, it readily communicate, the hypothalamic pituitary system readily communicate with the blood vessels that leading to your periphery system of the body. So we know that vasculature compromise is very common in diabetics and in patients with dementia. So I think that's very plausible. Shawn, I'm glad you mentioned. Yeah. So let's move on to some human studies. Actually, those studies all involves, so the first two all involve, say, PET scan or some sort of brain imaging modality. And I think the first one says elevated thalamic response to high sugar milkshake. Remember, it's the artificially concoctionated milk sugar. Basically, ensure is essentially a milkshake. In ethnically and racial minorities, I really like this story because we to be politically correct, we should care about them. But if we're, flooding the market with meat alternatives, we really expect and at a lower price, or try to kind of, introduce them into free school lunch programs. We really caring about the minority groups whose kids are really relying on, say, school lunch programs, or relying on the government to kind of subsidize them with food. And the second is a cell metabolism, which, if people know, was a quite reputable high profile publication. And this is from New York University, the super addictive effect of combining fat and carbohydrates on food reward. Also, this involves the imaging modality to show that reward sensing brain regions truly gets overly voraciously activated and can't correctly put a stop or activate the satiety sensation. The last one I particularly want to mention, it's actually a review article from Journal of Clinical Investigation. Shawn, you as MD, probably read a lot of Journal of Clinical Investigation studies. So what this study emphasized is that we have a particular sensor in our upper GI tract, the small intestine, to sense satiety. And this sensing mechanism relies on very specific type of fats that are found most abundantly in ruminating red meat. Beef is most abundant in it. They try to mimic this effect by giving fats of the similar mouthfeel but human cannot digest, namely mineral oil. They try to mimic this effect by giving fats of the same chain length derived from plants it cannot initiate this satiety signaling effect. It has to be the very specific fat that are found abundantly in beef. And I hope this is a reassuring message to our carnivore or, beef, red meat-based carnivore, beef-based carnivore community. Lastly, I just want to show that in currently for the majority of plant-based meat alternatives on the market, it's always a concoction of carbs and fat. And if you read where they get their fat, I'm sure they don't get their fat from, meat derivatives. It's all plant-derived fat, all synthetic fat. So with this, I just want to conclude with some very kind of bullet pointing type of thought that people could keep or, question in the future. You don't have to believe what I, said in the first go. Foods such as beef are important for correct neuroendocrine signaling of hunger and satiety. It's important for proper meal size and for long-term body weight management and metabolic health. So that concludes my little presentation. And I'll just stop sharing and go back to our meeting interface.
Yeah, thank you. And that was wonderful, by the way. I really, really enjoyed that. We always have, sometimes we have guests that will present some of the stuff, and it's really enlightening. One of the things, obviously, there's probably a lot more work to be done in this arena, and I'm sure you'll do some of that as you progress through your PhD, and you get some publications
I
behind
actually
you.
want to move to Kansas and be a cattle rancher.
I tell you that sometimes it's interesting that a lot of people after kind of seeing almost the peacefulness, the joy that it can be, is something that's interesting. But let me ask you, because now you're in this MD PhD program. I mean, I can't imagine that the people, they probably were familiar with the fact that you had problems with eating and anorexia maybe, and then they see you back. Has anybody noticed a difference in the folks you work with on a day-to-day basis?
Yeah, I think overall, I'm just a more pleasant person to be around. Before I was never like obnoxious, but I was driven in a way that's pushing people away from me. Yeah.
And does anyone that I mean, are any of your close personal friends or family, have they found that you're eating a meat-based diet? Do they have problems with that, or is that okay for them?
Oh, plenty, plenty. In my research institute, actually, it's I would say most academic environment you guys probably know are very left-leaning. So even say our survey just out of sudden start to introduce a whole bunch of vegan food items on the menu, and then they would make it so obnoxious that they highlight, oh, this food item is vegan on the menu. I just felt most people, I have to admit, most people do not approve or endorse the way I'm eating. And I just, by personality, I don't try to go out and then push people to adopt a carnivore diet. But I can tell you, one of my dear mentor, who is a Nobel Prize laureate for discovering circadian rhythm genes, he discovered the so-called PER gene. He is in Brandeis. So this dear mentor to me, he intermittent fast and he eats a largely ketogenic carnivore diet. So whenever he comes to scientific conferences, you don't see him grazing or eating during those breaks. Sean, when you attend meeting, all those kind of fatty foods are laid out, crackers and then donuts, cookies laid out. You never see him, even all the food are free, he can go eat 3 meals a day plus all the snacks he wants in between meeting breaks. You never see him grazing until his structured mealtime and he eats a carnivore diet. On his personal Twitter account, I think he would post pictures of him going out of the Boston Bay and fishing. He eats pretty much just beef and meat and fish, I would say. Yeah.
Yeah, I can confirm those meetings. I can remember sitting in certain orthopedic, surgical conferences, and they would have, obviously in the back they would have the cupcakes and the bagels and all the stuff, and then literally at your seat they would have little jars or little things of candy. I mean, there would be little Jolly Ranchers. You could sit there and eat those while you're listening to presentations. So it was a continuous flooding your system of sugar and refined carbohydrates, which is, clearly not an optimal diet by any stretch of the imagination. So you're correct on that. But
And just to
um,
circle back, someone who won a Nobel Prize, I don't think he's dumb for doing it,
no,
right?
I would argue that person is probably fairly intelligent, as are, many people that do this. I don't think this is about an intelligence thing. And I think, like I said, you've already tried the plant-based, and I assume, in the 9 years you weren't, the whole diet wasn't smoothies. I mean, at some point you were probably eating, uh, beans and legumes and all the other stuff that they
No, I actually tortured myself. I do horrible with beans and legumes. So
okay.
I was actually adding do you know the organ protein, that the brand organ that has vegan protein?
Yeah, I've
Like
seen that. Yeah.
I was relying on adding that into my smoothie to as a protein, as a vegan protein source, and it tastes terrible. So I can't add a lot. Like it's so repulsive that if I were to add the amount necessary for my body to maintain weight, it'll just taste so nasty. Yeah.
Yeah, I'd
And
rather have a steak for sure. Again, I'm glad that they put a big vegan on the label, because I know to avoid it. I think if I don't really buy or eat any kind of processed foods, so it's really not an issue for me. But I think it's something to, you could almost say I'm allergic to vegan food, perhaps.
right,
But
I guess my body wasn't designed to eat vegan from the first go. It's a very forced effort to try to eat it. Yeah. Yeah,
so
because my ancestry, if talking about it, I came to US with 2 suitcases from China for college. I did my college at Hopkins. I
Mhm.
double majored in molecular cellular biology and theoretical mathematics.
Yeah, those are a little bit disparate but interesting. Yeah, so obviously, you've got a fairly rigorous scientific background, and come to the conclusion that, one of the things, if you study nutrition science, and I've spent years looking at it, it's not a particularly strong science with regard to, the way we make conclusions, the way we design studies, and it's just tough. It's really challenging. I feel bad for the researchers because they can't really do any pure science on this stuff. It's really
Yeah.
hard to do a human study where at the end of the study you slaughter all the participants and cut them open and do autopsies. And I mean, the ethics behind that are not allowed. But
Yeah, what I
what you know
want
is
to bring to the community was, probably people don't see how the brain activity was actually being monitored and being manipulated as a organism, a mammal is performing a eating behavior. I hope to once I demonstrate this, it's really, you can willpower it out of the obesity pandemic.
Let me ask you, and I agree with that. I mean, it's not willpower. You can't exercise way out of the obesity epidemic. Although I think I do find exercise to be beneficial in other
True,
ways. But
certainly.
because you're using blue light to stimulate the arcuate nucleus, the lateral hypothalamic nucleus, and the parabrachial nucleus. How do you know you're stimulating which one? Is it a different wavelength of blue that you're using to do that, or how do you?
you
Because when
imp- you implant the stimulating electrolytes or the stimulating fiber. It's very fine. It's fine. It's almost finer than the human hair.
Okay, so the blue light is going directly on the actual nucleus. It's
Exactly.
not through
And
it's not through
uh,
optical eye stimulation.
right, we do it under stereotactic guidance. So the
I see.
positioning of the little fiber that stimulates it is very precise, and we always
I see.
confirm it by post hoc histology.
I see. Okay,
We cut
gotcha.
up the
So
brain to make sure we're stimulating the right place.
understand. Okay, interesting. So assuming you finish your studies and you get your PhD and your MD, and maybe you don't immediately become a cattle rancher, what do you have a specialty picked at, or are you going to continue in academic research, or what is your thought as far as going forward?
Well, if I don't immediately become a down-to-earth, good family care physician and also own a ranch in Kansas, I think I have two routes. One is to follow what we conventionally call research track residency. So it's usually offered by big academic teaching hospitals like Stanford, Harvard, Yale, where you go in to do a shortened clinical residency, but then you're hoping to be mentored by a senior researcher and then do a fellowship research to earn NIH grant. If you can produce enough body of work during your research track residency and then be awarded a National Health Institute grant, usually those universities or medical schools will promote you to have your own lab as an assistant professor. Alternatively, I actually also was considering going to Karolinska Institute Karolinska is where the Nobel Prize is awarded. It's in Stockholm. I was particularly interested in their program because they're the #1 in eating disorder study. I want to bring, the carnivorous type of diet into the eating disorder, refeeding, nutritional rehabilitation realm, which is currently completely lacking. No program, I would say, is refeeding anorexic or bulimic patient with a carnivore diet right now. But I also have some reservation in terms of pursuing those routes, because as I was saying, academic environment is usually, they put vegan labels on their subsidized food menu. So you have to be in an environment where you're happy.
Yeah. Well, yeah, like I said, sometimes you can change the environment. Sometimes you have to get in a place that's more supportive too. Well, we thank you so much for doing this. It's been really informative, and I wish you luck. And maybe, if you don't mind, maybe, a little farther down the road, you can give us an update on some of your research and how you're doing, if you wouldn't mind. That would be, I'm sure everybody here
Certainly.
would enjoy that.
Certainly, I hope I could stay in touch with Amanda and who organized the Meet RX community, and then I'm very much willing to volunteer my time to do whatever I can for the Meet RX team, just to promote the message. It's just be a volunteer member contributing to writing or bullet point generation work for the MeetRx team. May I keep in
Well,
touch with Amanda?
of course, well, that's up to Amanda, but I assume she's happy to do that, and we would love to have you as part of a more regular part of our community. So,
Thank you so much.
okay, thank you so much. It's Sunday. I know everybody wants to get back to their weekend, their families, and stuff like that. I've got some stuff I've got to do, run into the airport and stuff like that. So have a great day, everybody. We'll see everybody tomorrow. Hui, take care. Thanks again for doing this. Bye-bye now.